Hey everyone, a quick video on how to add and subtract fractions. So we've got two questions we're going to go through for addition and two questions for subtraction, and hopefully that will set you on your way to solving the questions below. Now we've looked at this already in year 4, so this is just some revision for you if you're going into year 5. So 2/5 add 1/5, or is it 1/5? 1/15. 2/5 add 1/15. How are we going to do this? We have two different denominators. We can't add or subtract fractions that have different denominators, and we have to make them have the same denominators. So what we know is that fifths and 15ths, they have a common multiple: 5, 10, 15. I can make an equivalent fraction that is going to be equivalent to fifths but is going to be in 15ths. What equivalent fraction could I make? 2/5 into 15ths. So if you're not sure about equivalent fractions, we're not going to look at it in detail here, but we should by now be really confident with equivalent fractions. So I'm going to roughly, very roughly, draw fifths. There's my fifths, kind of. Let me get rid of this and let me make a straight line here. That's a bit better. So here are my fifths. And what I'm going to do is make it a bit bigger here. I'm going to show, I'm going to show you my 2/5. So this is 2/5. And how do I make fifths? So these are fifths because there are 5 equal parts that make the whole, into 15ths. Well, I can just break them down like this and give something like that. And let's make it a bit better. There we are, something like that. Now I've got 3, 6, 9, 12, 15. Now I've got 15 equal parts, and my 2/5, which I shaded here, these are my 2/5, are now equivalent to 3, 6, 6/15ths, right? So I had 5 equal parts, but I cut them up into 15 equal parts. That's going to be 3 times as many equal parts. 5 times 3 is 15. 2 of my equal parts were shaded in purple, but those 2 equal parts, now I've got 3 times as many. So I've got 2 times 3 is 6. So 6/15ths is equivalent to 2/5. And so I can rewrite 2/5 as 6/15ths instead, because I know the equivalent is nearly the same thing, right? Just different name. And now I can add my 1/15th and I get 7/15ths. So 2/5 add 1/15ths is going to be 7/15ths. And that's my answer. How did I do that? Well, first step is to make equivalent fractions so that we have the same denominator. I had 5 and 15 as my denominator. I made the 2/5 into 6/15ths, and that allowed me to add the 1/15ths to the 6/15ths to get 7/15ths. When we have the same denominator, we can add the numerators to get 7/15ths in this case. But what happens when 3 and 8 in this case are the denominators, and we don't have a way of just multiplying one of these and finding the equivalent fraction for one of these so that I can add it onto the other? Well, that's when we have to think about the 3 times table and the 8 times table in this case. 3 times table: 3, 6, 9, 12, 15, 18, 21, 24, 8, 16, 24. The first number that appears in both the 8 and 3 times table is 24. And so if I put this aside, then 3/8 and 1/3 can be written as something over 24. Can you think about what that's going to be? Can you work that out for me? Maybe you want to pause the video and try it out. Well, 3/8 is equal to something over 24. I know 8 times 3 is 24, so I'm going to multiply my numerator. 3 times 3 is 9, and so 3/8 is equivalent to 9/24. 3 times 8 is 24. 1 times 8 is 8, and so 1/3 is equal to something over 24. I'm going to multiply 3 times 8 to get 24, so I'm going to do the same thing for my numerator. 1 times 8 is 8, and that's how I get my 8/24. So now they're both over 24, so I can add the numerators, and I get 17/24. 9/24 add 8/24 is equal to 17/24. Does that make sense? Have a go at some of the questions maybe below if you can, or let's go for our subtraction questions and then you can have a go at the whole quiz below. The nice thing about subtraction is it's exactly the same technique, but we just subtract. So let's have a go at this one first. 3/4 take away a 1/6. So I'm going to rewrite this so that we have the same denominator. What's the first number that's in the 4 and 6 times table? Some of us might just do 4 times 6. That's not the first number. You can do that to work out the denominator that they have in common. But if you think about it, 6, 12, 12 is a number that's in the 4 times table. So I can actually make these out of 12, right? 3/4, 4 times 3 is 12. And so 3 times 3 is 9. And so I get 3/4 is equivalent to 9/12, and 1/6 is equivalent to, or 6 times 2 is 12, so 1 times 2 is 2. 1/12 is equal to, or equivalent to 1/12. 1/6 is equivalent to 2/12, and therefore now I can do 9 take away 2 is 7, and this is going to leave us with 7/12. So 3/4 take away 1/6 is equal to 7/12. Does that make sense? Have a go at the last question, and then you can have a go at all the questions below. 2/5 take away an 1/8. So 5 and 8, what's the first number that's in the 8 times table and 5 times table? 8, 16, 24, 32, 40. So 40 would be in both of these times tables, right? 5 times table and 8 times table. And so I know I can make both of them out of 40, right? I can make an equivalent fraction. 2/5 is equal to something 40ths. I know how to do that. It's 5 times 8 as a denominator, so I'm going to do the same thing for my numerator. That's 16 40ths, and 1/8 is equal to, well, I know that 8 times 5 is 40, and so 1 times 5 is 5, and so 16 40ths take away 5 40ths, you're left with 11 40ths. So 2/5 take away 1/8 is equal to 11 40ths. Have a go at the questions below now and see how you get on.